We're now going to turn our attention to some factory method operators in the Flux class that are more powerful than the simple ones we looked at before, like just, from, iterable, from, and from array. And now that you've been introduced to the concept of concurrency and schedulers, some of these operators are going to make a little bit more sense, and we can talk about them more holistically. So you all know a factory method, what it does. It creates something. These create Flux streams in various ways. And the three methods we're going to talk about are create, range, and interval. So let's talk about each of those in turn. We'll start by talking about create. This is a factory method that makes a flux that can emit multiple elements either synchronously in the calling thread or asynchronously in some background thread. And it's got a really wacky parameter here, which is a consumer to a flux sink called an emitter. And as the name suggests, this parameter emits any number of next signals followed by 0 or 1 error or completion signals. That should sound vaguely familiar because that's kind of the basic streaming model with fluxes or reactive programming in general. This factory method allows much more dynamic use cases than the simple things we've looked at so far, like from and just and from iterable. So those were very, very, especially just and from iterable, they were very static. But even from doesn't get you as far along as this one does. This returns a flux that will emit all the elements generated by the parameter called a flux sink. So this gives you sort of arbitrary hooks to generate arbitrary things in arbitrary ways, but get them flowing out into a nice, well-designed, well-structured flux stream. So here's a very simple example that shows how this works. This is illustrating something that will work synchronously. And what it does, we have a little helper method that I put into my Reactor Utils class. And it takes in a supplier and a count, and it's called generate, and it returns a flux. And what it does is it uses flux create, and synchronously it creates a little lambda expression, which is the flux sync thing, and it's wrapped up in a consumer. And what it's going to do is it's going to say for I equals 0, I less than count, I plus plus, get whatever supplier gives you, whatever get from supplier provides, take that and emit it as the next event up to count of these. Let's say count is 10, just for be specific. So it'll do 10 calls to supplier.get. And when that's all done, it'll call sync complete to indicate to the flux stream we're emitting, we're all finished, everything worked fine. Now again, this runs synchronously. It runs in the thread of the caller. So what's interesting about this is you can also use this to emit elements from one or more background threads, which is very, very powerful. And it also leads to these impossibly hard to read marble diagrams that show this thing. I look at this stuff and I'm like, what the heck is that trying to say? But what it's trying to say is you can have things emitting stuff in the background. Looks like somebody took, you guys probably don't remember this from your childhood, but when I was a kid, we had these things called spirographs, where you could like draw stuff in various concentric circles. That was really cool. And that looks like a spirograph drawing. RxJava has a class called flowable with a create method that works the same way. However, the data types that are passed are slightly different because why not? Let's just make things different. There's a similar method in Java Streams called generate. And the Java Streams generate method will take whatever you pass it, which is basically a supplier, and just keep doing stuff over and over again forever unless you limit it by some limit operation later in the stream. All right, so that's create. Let's now talk about interval. Interval is an operator that will create a flux that will emit long values starting with the value 0. And you can give it a period that says how long interval should wait before it generates the next value. So you can say every second generate a value from 0 to infinity. And this returns a new flux that emits these numbers, these increasing numbers, monotonically increasing numbers, at regular intervals, whatever the duration is. By default, it emits the values on the scheduler's parallel scheduler. So there's a scheduler called parallel scheduler. We'll talk about that later. It's a variant of the new parallel factory method, but it's baked in and it uses daemon threads in the background. So it'll emit that back there. However, there's a whole boatload of other overloaded interval methods where you can provide the scheduler that you want. So you can say, I don't want it to run on the parallel scheduler. I want it to run on some other scheduler that I'm going to provide. Under normal conditions, the flux that uses intervals will never complete. So it'll generate those values forever or until, I guess when it wraps around, when you reach the end of the size of long, it'll wrap back around again. But the point is it goes on forever. So this particular approach will generate a stream of longs every half a second in a background thread from the parallel scheduler. And I mostly have this slide just because I really like that particular animation. It looks like infinity or something like that. So since most people don't want your programs to run forever, a good thing to do is use the take operator, which we're going to talk about in just a bit. And take is what's called a suppressing operator, and you can limit the number of these values that are emitted up to that many. So let's say it's 100. This will emit values starting at 0 every half a second up to 100. There's an interval method in RxJava that basically works the same way. And there's really nothing in Java streams other than to use the generate method we looked at before a moment ago, which you could put like a sleep to generate every half a second or whatever your time frame would be. The third and final factor method we're going to talk about in the context of Flux at the moment is the range operator. And that's going to return a flux that will only emit up to count values starting from start. So basically it's like a reactive for loop. And it says start at start and go up to start plus count, and then you're done. The onComplete method will be invoked. So basically it's a ranged flux containing count elements from start to start plus count. So here, as I just said, it's like a reactive for loop. Here we can say flux.range 1 to s max iterations, go to town. And then you can do stuff after that. RxJava has an observable range method that works essentially the same way. Not too interesting. And these are both very similar to the stream ranged closed method. There's an int stream that can generate these. There's a double stream that'll generate doubles, and a long stream that'll generate longs in much the same way, same basic idea. So that's the end of the factory method operators that we've talked about. There's yet more of them, believe it or not, but this is a good start, and you'll have more than you need to know for things we're doing with our projects.